So in this density lab, the first thing that we're going to do is to determine the density of various solids. And we have several different metals that we're going to be determining the density of. The first one is aluminum. So we have here a piece of aluminum. And remember, density is a ratio of a substance's mass to its volume. So we can easily measure the mass of a piece of aluminum by using our balance. All right, so we can open it up, we zero it, and then we can place our piece of aluminum. We can record the mass. When it comes to measuring the volume of the piece of aluminum and all the other metals, we're going to use the displacement method. And this method is fairly straightforward. So what we have here is a graduated cylinder. We have it about halfway filled with some water. So we're going to record what that initial volume of water is. And then we're going to gently add in our piece of aluminum in this case. So we're going to tilt our graduated cylinder a little bit so to gently slide this in. And then what you'll notice is that the volume of the liquid went up. So in other words, the aluminum displaced a volume equal to its own volume. So we can then record what that final volume is. If we take the final volume, we subtract it from the initial volume, or we subtract the initial volume, we get the volume of our metal. So we're going to use that technique for all of the samples, all the metals and also the pennies, to determine the volumes. Once we have our volumes determined, we measured the mass previously, we can simply divide the mass by the volume to calculate the density of our samples. Okay, so in this part of the experiment, we're going to be determining the density of a couple different liquids. And we're going to start first of all with some rubbing alcohol, which is also known as isopropyl alcohol. So what we're going to do is we're first of all going to measure the mass of an empty graduated cylinder, and what we're going to do after that is to add in different volumes of the isopropyl alcohol. So we'll first get we'll measure out 10 milliliters of the isopropyl alcohol, we'll measure the mass of that, then we'll add 15 milliliters of isopropyl alcohol, get the mass of that, and then we will measure 25 milliliters and get the mass of that as well. So we can then subtract the mass of the empty graduated cylinder to get the mass of each of those three different samples of the rubbing alcohol. We know the volumes that we're going to be measuring in each case. We can divide the mass by the volume to determine the density of each of those. We're then going to repeat that process, and we're going to determine the density of three different samples of just regular deionized water. Okay, so we have the mass of our empty graduated cylinder recorded. We're then going to add in 10 milliliters of deionized water to this, and then we're going to get the mass of this sample. Okay, so we can then subtract the mass of the empty cylinder to get the mass of that 10 mils of water. We can then divide the mass by the volume to determine the density. So we'll do that for three different samples of our water. Okay, so in this part of the experiment, we're going to be making a rainbow density column. So we have here 4 different solutions of sucrose. Sucrose is just regular table sugar, and they are colored differently. So we have purple, we have green, we have yellow, and we have red, and they just represent different concentrations of the table sugar. So for example, the purple one is an 8% sucrose or table sugar, the green is a 6%, the yellow is a 4%, and then the red is a 2% sucrose or table sugar solution. So what we're going to do is to slowly pour 2 milliliters of each of these solutions in here, starting with the most dense solution, and then we'll eventually add all 4 of these. Okay, so starting with our most dense, the 8% solution, we're going to add about 2 milliliters of the solution in here. So we'll tilt the graduated cylinder a little bit. Then we're going to slowly add the next one, the 6%. Then we're going to add the yellow, which is the 4%. And then we're going to add the red one, which is the 2% solution. Okay, so here you can see the rainbow column. We have the purple at the bottom, the green, followed by the yellow, and then the red is at the top. Okay, so now we're going to take our rainbow column and we're going to shake it and observe what happens to the solution. Okay, so we've just shaken the rainbow column. Let's shake it a little bit more. And then you can see what happens to the colors that were there before.